Hello, my name is Jerry Knapp. I'm the chief of the Rockland County, New York Hazardous Materials team. In this segment, we're going to discuss low alarm and high alarm on your 4-gas instrument. Before we do that, I have a question for you. Why is your low alarm set at 10% LEL? Most firefighters say to give us some response time before we get into a hazardous area as the LEL climbs. The real answer is it's set at 10% because that's the confined space standard that OSHA specifies that if you reach 10% LEL in a confined space, you either have to get out or ventilate. There's no national standard for an action level for firefighters in a natural gas or a propane environment. That action level needs to be set by your own fire department and your own procedure. I'd recommend 10 or 20% LEL. The instruments alarm or typically are set to alarm at those levels, so it's a good action level for you. So we're going to put this into the explosion chamber here. This instrument is a particularly good 4-gas. It actually has a high alarm at 50% LEL. So low alarm is 10% LEL. You'll see the instrument flash slow. At 20% LEL, it will flash faster and start to vibrate. And at 50% LEL, it will go into what we call high alarm. It also, most 4-gas instruments like this shut off at 100% LEL. This will go a little bit over 100% and it'll actually read 100% LEL. A lot of other 4-gas instruments, when they reach 100% LEL, which is obvious dangerous place, it will be 3 stars. Some instruments have like quotation marks. So the untrained firefighter, he or she doesn't know that they're in a very dangerous place unless they've read the manual, which, by the way, if you have an instrument, any kind of 4-gas, you need to read the manual. Read the manual, read the manual. It's the most important thing you can do. So I'm going to put some gas in here. We'll watch this instrument go into alarm. So it's picking up flammables now. Just went into low alarm at 17% LEL. 20% LEL, it's going faster, the alarm. 38% LEL, climbing through the 40s. Oxygen is down to 20.6. We'd expect that because we pushed out some oxygen with the propane I put in there. I just put a little more propane in there. Oxygen's down to 20.6. We just crossed the 50% LEL mark. It's into the high. We're going through the 60s now. Climbing through the 60s and the 70s. Oxygen is down to 20.4. We'd expect that. Again, we're seeing a displacement of gas, displacement of oxygen by the gas. We're at 93% LEL and climbing. $99, we just hit 100% LEL. Again, this instrument goes a little bit beyond 100% LEL. Most instruments don't. You can clearly see oxygen is down to 20.1%. Something interesting, carbon monoxide is showing at 7. The reason for that is the electrochemical sensor, the carbon monoxide sensor, which is an electrochemical sensor. An electrochemical sensor is this. There's a chemical on top here that reacts to whatever the particular sensor is. In this case, it's CO. So this chemical reacts to carbon monoxide. There's a little bit of an electric reaction there from the chemistry, and then it's turned into, by electricity, a number we see. So again, the carbon monoxide sensor is cross-sensitive. We just proved it's cross-sensitive to propane. If you read your manual, you'll find out it's cross-sensitive to 2 other gases, which are really important to firefighters. One is hydrogen. Hydrogen is highly flammable. Where would we see hydrogen? There's a couple of common places. Lead acid batteries that are overcharged will drive off hydrogen. In the sulfuric acid, in the lead acid battery, there's hydrogen. the chemical formula for sulfuric acid is H2SO4. When the acid breaks down, the H, or a hydrogen, comes off. It's highly flammable. We may see this in some pumps that have a battery backup that have been overcharged, truck or car batteries, forklift batteries that are overcharged, maybe a source of hydrogen. You may find hydrogen in industrial applications as well, but for us, we'll see it typically with overcharged batteries. Again, if you read your manual, you'll find out that your CO sensor is most likely cross-sensitive to another important gas to us, acetylene. Acetylene is highly flammable and explosive. It's, as you know, it's an unstable gas. The flammable range for acetylene in hazmat terms is if that stuff comes out, it's going to burn, right? The flammable range for acetylene is something to 100. If it comes out, it's going to burn. Another important reading we saw on our meter, our foregas, is the oxygen went down. You should be looking at, that's probably the most important sensor in your unit. A 1% drop in oxygen, so 20.9 down to 19.9, indicates there's 50,000 parts per million of something else in there. We don't know what. We saw the oxygen level go down here because it was driven out, the oxygen was driven out by propane. In the real world, you won't know what that gas is, but if you see a reduction in your oxygen by more than like 0.2% LEL, you got to assume something is there pushing it out. You need to be doing your detective work to try to figure that out. Recently in Phoenix, Arizona, firefighters responded to a McDonald's. When they went into the basement, their oxygen reading went down, and the reason it went down is the carbon dioxide in the soda system had leaked into the basement and displaced the oxygen, and there was actually a woman downstairs who was overcome and was unconscious, which is why the fire department was called in the first place. So your oxygen reading is important. If you lose more than 0.1 or 0.2% oxygen, you need to really be looking around to say, hey, what else is here?